Absolutely. 8 Rivers, we invent and commercialize carbon capture technologies. And one of our newest technologies, 8RH2, is a way to make clean hydrogen from natural gas with full carbon capture. So there's a breakthrough technology, and Cormorant is going to be the first place that we deploy it, facility. So we're taking a natural gas, we're making hydrogen, we turn that hydrogen into ammonia, which is the major ingredient in fertilizers, is maybe where you know it from. We then send that ammonia all the way over to Korea, where they can use it as a fuel to displace coal in their power plants. So, what we're doing here is we're using the US's abundant energy sources and our CO2 storage, where we can actually not just take energy from the US, but we can store the CO2 before we export that energy product. And instead of exporting, say, liquid natural gas, LNG, which when your customer across the world burns it emits CO2. If you export ammonia, we've already done all that hard work of capturing and storing the CO2. And so we can export a decarbonized energy product. Korea is a big energy importer, and our major investor, SK Group, is one of the big conglomerates out there. And so they are looking to actually use ammonia as a fuel that they can import. They can burn it in their existing infrastructure without emitting any CO2. So this is a project that'll be in Port Arthur, Texas. We'll be producing around 880,000 tons of ammonia. So over $1 billion of investment that will be required to make this a reality. And that's something we're really excited about, both for what it can do in the US and in Texas, what it can do in Korea, and the technology that will be deployed there that we can then rinse and repeat and use to help decarbonize fuel in many other applications. That's right. We need a lot more hydrogen to decarbonize, and there's two main places we think we'll get it. We think we'll use electrolysis, which is turning clean electricity into hydrogen. The challenge there is you need to have an abundant source of clean electricity that wasn't going to be used otherwise. And so there are places where you've got tons of solar and wind that's got nowhere else to go. That's a great place for electrolysis. You can also take all of that current, steam methane reforming, all that current hydrogen production. We can clean that up too. Right? We don't need to wait until we build terawatts of solar and wind around the world, and we don't have time to wait. And so we think you're going to have two prongs to decarbonizing hydrogen: electrolysis and also carbon capture um, on that natural gas derived hydrogen. Thanks for the questions, and I think we could have gone for a couple more hours.